Next 10 minutes I am going to present a road to Maxwell equations. That means from basic electromagnetic law, Maxwell equations derived. So I am going to explain the path for the Maxwell equations. That's why it is called a road to Maxwell equations. So we know that the basic Ampere's law, integral H dot dl equal to I. Faraday's law says voltage induced equal to rate of change of flux linkages. Gauss law says flux equal to charge enclosed, and Bayes' law says integral of B dot ds equal to 0. From that the Maxwell equations is derived. The meaning is when you take the Faraday's law, the Maxwell equation is curl H equal to J plus JD. Then Faraday's law, curl E equal to minus dou B by dou T. Then from Gauss law, the Maxwell equation is divergence of D equal to rho V. Then from Bayes' law, the equation divergence of B equal to 0. Okay, that means Ampere's law, this is Ampere's law, for that this is a Maxwell equation. Faraday's law is a Maxwell equations. Gauss law, this is the Maxwell equations. Bayes' law, this is the Maxwell equations. So what is the contribution of Maxwell in Ampere's law? So this I want to going to explain. Just to take Ampere's law. The Ampere's law says the tangential component of H for a closed path L is equal to I enclosed. So that means if you take the I concept, then the line integral H dot dl equal to double integral of J dot ds. This is nothing but current. Then using Stokes theorem, this line integral makes to surface integral by taking curl H of ds equal to double integral of J dot ds. So for the same surface, curl H equal to J. So curl H equal to J is the one of the concept. If you take the divergence on both sides, it becomes divergence of curl H, which is equal to divergence of J. We know that divergence of curl is nothing but 0. That means divergence of J equal to 0. Then from continuity equation, the same concept becomes divergence of J equal to minus dou rho V by dou T. Okay, there is some controversy between divergence of J equal to 0 as well as divergence of J equal to minus dou rho V by dou T. So Maxwell combined these two concepts to make another equation, so that Ampere's law is modified into another form. That's why it's called modified Ampere's law. That is contribution of Maxwell. How it developed, we know that from the law of conservation of charge or continuity equation, divergence of J equal to minus dou rho V by dou T. From Gauss law, dou by dou T, the divergence of D equal to rho V. Okay, that means minus dou by dou T, take the del outside, that time it becomes del dot minus dou D by dou T, that becomes minus del dot JD. So the JD is called displacement current density JD as dou D by dou T. So making that left hand side divergence of J plus divergence of JD equal to 0. That means divergence of J plus JD equal to 0. So you combine these two expressions. That time from basic Ampere's law, combining these two equations, that time divergence of J plus JD, divergence of J plus JD equal to divergence of curl H. So combining this, curl H equal to J plus JD. So this is the modified Ampere's law. The basic Ampere's law says curl H equal to J. J is called conduction current density. JD is called displacement density current. That means from the basic Ampere's law, curl H equal to J, it is modified by the Maxwell. So it becomes J plus JD. That means the magnetic field is induced due to the magnetic current I. Also, the magnetic field is induced due to the displacement current. That is called a change in electric field. So J plus dou D by dou T, which is equal to J plus dou by dou T of D is nothing but epsilon E, which is nothing but J plus epsilon of dou E by dou T. So according to the Maxwell, the magnetic field is induced not only because of J, as well as change in electric field also causes the magnetic field. So change in electric field also creates the magnetic field. So that is the main contribution of Maxwell. Then from the Maxwell equations, from the core concepts, curl H equal to J plus JD. This is from Ampere's law. Then curl E equal to minus dou B by dou T. This is from Faraday's law. So in both the concept, divergence vanishes. No divergence exists. That means if you take any one conductor, then the conductor is allowing a current I. So when the current flows through the conductor, the magnetic field circulates. So the curl exists. So curl exists means there is no outflow from that body. Therefore, divergence of H equal to 0. Similarly, divergence of E equal to 0 for the magnetic field. Similarly, if you take the electric field concepts, divergence of D equal to rho V is the Gauss law. Then divergence of B equal to 0 is nothing but Bart-Savart's law. So divergence of D equal to rho V, when you take the curl concept, then divergence of curl of D equal to 0. That means no circulation exists in electric field. Then if you take the Bart-Savart's law, divergence of B equal to 0. That means no outflow of flux. No outflow of flux because only the curl exists. Curl exists, divergence becomes 0. Okay, so these are the 4 modified form of the Maxwell equations that also derived from the basic electromagnetic laws. Clear?